I'm going to demonstrate setting up common backup strategies for a 4D database. There are a lot of ways to handle backups, and which one is best depends on a number of factors. I'll walk through several strategies and discuss the points to consider when choosing the right one for you. Plus, I'll have my own recommendation. I'm using 4D 20.6 LTS in project mode. The days when backup meant you just copy what's there and move on are way behind us. Performing backups of production data is more important than ever. And because of how varied a 4D database can be in scope and operation, taking care of backups has become a little bit complex. To begin with, there are actually two parts of a 4D project that you may want to back up: the data and the 4D code. This video is focused on backing up the data. Backing up 4D code and other aspects of the project is usually handled separately now, most often through Git or another version control system. Also, in this video, we're focused on production data, the actual live data used by a company or organization. Most of these concepts apply to desktop projects too, but I'm mainly talking about 4D server. So, first, you need a backup strategy. Choosing a strategy depends on the size of your project, the size of the data, the amount of activity in the database, and your availability requirements. For the most part, the data means the 4D data file, the proprietary data file where 4D stores all of your records. And by the way, being proprietary is not the same thing as being encrypted. It's not encrypted by default. A determined hacker could extract data from a 4D data file without needing the database it belongs to. We can cover encryption options in another video. In most cases, the data file is the only file that you must have to restore a database. Other files, such as indexes and the data journal, may be backed up too. But without the data file, none of those others matter. First, there's the size of the data. Smaller data files back up quickly, meaning that you can make them frequently without interruption. Medium-sized data files take longer and may have a noticeable impact on users if they run during operations. You want to schedule these backups for off-peak periods. And large data files can take significant time to back up, meaning that you have to plan carefully for them. Availability is another consideration. How critical is database availability? Is it as needed, meaning there is no significant downside if the server is offline from time to time? Or is it more like 23/7, meaning that you're willing to tolerate occasional downtime, maybe a few minutes as long as an hour each day? And finally, is it 24/7 and there is simply no downtime acceptable? And then lastly, there's the amount of activity in the database. Have you got a few users and a small number of records being added or updated? Or do you have dozens of simultaneous users, perhaps a web server or other connections adding and modifying records throughout the workday? Or do you have an enterprise system at its heart, running 24/7, perhaps with hundreds or even 1,000 users, web servers constantly adding and modifying data all the time? All this matters because when 4D backup runs, the server hits pause. 4D completes any transactions and other operations, causing data to be written. It queues up any new requests while this is going on and devotes its entire attention to producing the backup file. Once the backup file is complete, the server resumes normal operations, starting with any requests that came in while the backup was running. This is why you want to avoid backing up large data files during peak hours, because it can create a noticeable interruption for the users. But if you have a small data file and it's not very busy, then backups can often be done without anyone even noticing that it's going on. The time it takes to perform the backup depends on various combinations of factors. You'll need to observe your system to judge what's acceptable and how to schedule it. One way to think about backups is by looking at the risks you're trying to mitigate. What happens if you have no backup at all? What happens if you lose a day's worth of data? A week's worth? What happens if you lose the physical location of your database? That means the building burns down. How hard or even possible would it be to recreate lost data? Here's a list of some specific risks to your data file. Think about them as you go about setting up your backup strategy, about how your backups will help mitigate these risks. This helps you weigh the cost you're willing to bear to protect your data against the risk that any of these might happen. Let's take a look at setting the backup settings for 4D. You can get to the settings screen several ways. In design mode, settings is at the bottom of the design menu. You can frequently access it through the file menu. You can access it through a 4D file menu, and you can provide access through your user interface. Let's take a look at each of the tabs of the backup settings screen. Tab 1. This page gives us the scheduler. This lets you design a backup schedule, and 4D will follow it. There are many options. You can also handle initiating a backup through code. Tab 2 is the configuration tab. In this example, I'm backing up the data only. In the attachment section, I'm deciding to back up the indexes also. If I didn't include the indexes, 4D will rebuild them when the backup is restored. So why do you want to back them up? Well, it depends on your needs. Rebuilding indexes can be time consuming, depending on the number you have and the hardware you're using. Backing them up may be worth the time and storage space. On the other hand, you may prefer to not back up the indexes and simply let 4D rebuild them when you restore. And the destination folder for your backups is the location the backup writes to. You want this to be fast. Attached SSDs are preferable. You do not want to write directly to NAS or other network backup locations. Instead, write to an attached SSD and then copy the files to the NAS once the backup is complete. I'll talk more about this in a minute. The log file. The backup log file or data journal is a really important file. I can't think of a reason you would not want to use the log file. 4D stores it next to the data file, and a new log file is created after every backup. This file records every change to the data file as it happens. It's like a ticker tape. The log file records every action affecting the data. This happens independently of the actual database operation, so keeping the log does not slow down database operations. A new log file starts after every backup and accumulates data until the next backup. At that moment, the log file includes a step-by-step history of changes to the data since the last backup to the current backup. It is the history of operations that took place on the data file since the last backup and results in the data file that is now in the current backup. And it can be converted from its binary format into JSON format with the log file to JSON command. You can inspect the log during operation from the MSC. Leave a comment if you'd like me to make a video exploring more details of the log file and how you can use it. There are a lot of options on this tab, allowing you to specifically tailor the backup plan you need. Many of these are extremely detailed and useful in edge cases. In this video, I'm going to cover the ones I think that you are most likely to know about. Take a look at the documentation for details on the ones that aren't covered or that you may have more questions about. Uncheck the box if you want to keep all backups. Otherwise, specify the number that you want to keep on hand. Once that many are on hand, 4D will delete the oldest one when a new one is added. Don't make this number too low. You may not always realize when there's a problem with your data. Ransomware attacks, for example. Ransomware will often wait for some period of time before running. If you have a backup made before the incursion, you can recover your data at least up to that point. Otherwise, you can't. Backing up only if the file is modified is a good plan for a database that doesn't get a lot of use, or in a case where you are saving frequently, like every hour. Segment size is something that used to be an issue in the days when we were backing up to DVDs and zip drives. It is rarely a consideration today. The compression rate impacts how fast the backup runs. No compression is the fastest, but basically just copies the data file, so it also takes the most room. Compact gives you the smallest backup files, so you're using less room, but it takes more time. And fast is somewhere in the middle. Interlacing and redundancy have to do with mitigating risks of drive sector damage, interlacing, and security through duplicating the data, redundancy. Both these options increase the time and size of backup files. Log integration is something to think about. The default is strict mode. When an error occurs during integration, it stops and you have to use the MSC to trace the error. Automatic repair mode tells 4D not to stop for non-critical errors and to repair them if possible. These repairs are journaled to the logs folder and you can analyze them later, but 4D will just keep rolling in the face of them. These are errors like attempting to add a record from the journal, but it already exists, or to update or delete a record that doesn't yet exist. Mode is good when you want to know about any sort of backup error or restore error right away. Automatic repair might be better for systems where it's important that the system be up and running, even if it means that you may have some data errors. What do I suggest? My recommended schedule is to back up daily, typically during off hours so as not to impact users, and to always use the log file. This will work for 95% of projects. If you feel you need more frequent coverage, think about copying the log journal. It makes the restore a little more complicated, but it has zero impact on users and doesn't take up as much room as a full backup. Now let's come back to where to put the backups. I showed you a simple folder just right next to the data file itself, but data is difficult or impossible to replace. So what if we want our backups to be really safe? Here's a quick list of some locations to store your backups. You're not limited to just one. In fact, you should have at least two backup locations. And here's some good news. Simply having a backup at all, even on the same machine as the database, protects you from more than half of the common risks that we brought up at the beginning. But you still have serious risks that only offsite or cloud backups can cover. Things like theft, building damage, that means the building burns down, or natural disasters. The moral of this story, you need at least two backups, preferably including an offsite one. And there are a lot of ways to manage multiple backups. You could use Dropbox, iCloud, rsync, cloud management, other providers. But that's a topic for another video. Let me know below if you'd like for me to cover that too. Now let's talk a little bit about Time Machine. This is mainly aimed at you Mac users out there, and that is me as well. But this also applies to a number of other NAS type storage devices. If you're a Mac user, you probably rely on Time Machine backups. And if you have your 4D server running on a Mac, you may think that Time Machine has you covered. It does not. A 4D server is frequently writing to the database, not just when the user enters new data, but also for background operations. You can't know exactly when, and Time Machine can't know either. Even if your Mac is using APFS snapshots, Time Machine still doesn't coordinate with the 4D server. It might capture the database mid-write, creating an inconsistent or corrupted copy. Because the 4D data file is a single large monolithic file, even small changes force Time Machine to treat it as an entirely new file. This makes backups huge and slow. Worse, each Time Machine copy of the database carries a risk of corruption. The result is that the Time Machine is just not a safe backup method for 4D server. It can be used in addition to, but it's not a replacement for. On the other hand, if you happen to be on Windows, Windows Volume Shadow Copy is a backup tool that does make a reliable snapshot of a 4D server's data file, index, and journal while the server is running. 4D Server now also supports snapshots in virtual machines for an even more robust set of backup options. On the Mac, however, there is no native equivalent to Volume Shadow Copy. Time Machine cannot coordinate with 4D Server or ensure a stable snapshot. This is a major reason why Time Machine alone is not the reliable backup solution for a live 4D database. So, there you have it. Backing up with 4D. Use 4D's built-in backup tools whenever possible. It's technically possible for you to do your own backup scheme, but it is a lot of work, and in the end, it just may not be as robust as the one 4D has built. It's not a wheel that you need to reinvent. Protect your data. It's your most valuable asset. Thanks for watching. Leave a comment or question below. There are also links if you want to dig a little deeper. And I'll see you in the next one.